The next thing we are interested in while speaking of multidimensional scaling is similarities. So we have a two-dimensional space here. And the x-axis stands for the size of the company, and the y-axis stands for the profitability or the profit margin of the company. So the first company here on the right is a big company with a small profit margin. And the second company here on the left is a small company with a big profit margin or big profitability percentage. Now, how to measure how similar these two companies are? So first of all, what might pop into our heads would be, let's see how long is the straight line distance between the two companies. How far away from each other are they? That can easily be done. So for that we will be using actually what is the Pythagorean theorem. Let's see how. Our coordinates are 5, 1, 1, 4. And now we are going to build a right triangle that is going to have the horizontal difference here. So that's 5 minus 1. The difference between the two x-axis coordinates. And the vertical distance here, 4 minus 1. The distance between the two y-axis coordinates. So here it is. We measure these two. These are 4 and 3 respectively. And now it only is a matter of applying the Pythagorean theorem to calculate the straight line distance between these 2 points. So it's the formula was as follows: 4 squared plus 3 squared, which is 16, plus 9, which is 25. Well, 25 squared, and now if we take the square root of 25, we get 5, and this is the straight line distance according to Pythagorean theorem. So we have a right triangle with its 2 cathedra and its hypotenuse, or its 2 sides and its hypotenuse, and we measured the straight line distance between the 2 points. This just so happens to be the favorite triangle of Pythagoras, who was a numerologist himself. He believed in the magic of numbers, so 3, 4, 5 was kind of his favorite triangle. Okay, so we have 2 bits of information, but what if we have 3 bits of information? How to measure the distance then? Let's say that the third bit of information is how much loans do those companies use, and the first one, the big company, doesn't use any loans at all, and the other uses loans to some amount. So here's the picture. We have 0 as the z-coordinate for the bigger company, and 2 as the z-coordinate for the smaller company. The propensity of using the propensity to use loans. What we need to do then, we need to apply Pythagorean theorem twice. So at first we throw away the z-coordinate, and we're left with this small company point and this big company point. And we do the Pythagorean theorem: 3 squared plus 4 squared equals 25, square root equals 5. We get the distance as in the case when we've thrown away the third dimension. Okay, now now we add the third dimension back on. So the big company had 0, the small company had 2, and you see we can create a new right triangle here. One side of the right triangle is this 5 we've calculated. The other side of the right triangle is this 2, which is the difference along the z-axis. And when we calculate this resulting new right triangle, we get 2 squared plus 5 squared equals the straight line distance. 2 squared plus 5 squared is 29. Square root of 29 is the right straight line distance. And as we can see, when we have 3 dimensions, it is the matter of applying Pythagorean theorem twice. The second application will go towards seeing what is the difference in along the z-axis. So it was 0 and 2 right now. It could have been 1 and 3, and then the difference would still have been 2. So it's the difference along the z-axis we're looking at. And now it turns out that we are going to be able to apply this even if we have 4 bits of information. Only in that case we say that our space is 4-dimensional, something we can't imagine possibly. And we apply the theorem for the third time as well and get the straight line distance between now those 4-dimensional points. 4-dimensional being in quotation marks because we just don't imagine this higher dimensional space anymore. But it can be 5 dimensions or 80 dimensions. Actually, if you look at the formula of Pythagorean theorem, then it's square root delta x squared plus delta y squared plus delta z squared. So it means that if we have now 4th dimension, we just put its delta squared inside the square root again, and we just add those dimensions, and the formula will work perfectly in a higher dimensional room as well. So that's how we can measure similarity between companies, even if we have a company with 80 bits of information on it and another company with 80 bits of information. We just measure the distance along each bit of information and square them up and put them as a sum and take the square root from them. And we get the distance between them too. Well, if we want similarities, we can do 1 divided by distance. So if distance is 2, then similarity is half. But on that, let's speak more later.